So let's see the third one. The two balls x and y move along a horizontal frictionless surface as illustrated in figure 3.1. Ball x has an initial velocity of 3 meters per second in a direction along the line AB. The ball y has a mass of 2.5 kg and an initial velocity of 9.6 meters per second in a direction at an angle of 60 degrees to the line AB. The two balls collide at point B. The balls stick together and then travel along the horizontal surface in a direction at right angles to the line AB as shown in figure 3.2. So here the ball A is coming along the horizontal direction with a velocity 3 meters per second, and the ball Y, which has a 2.5 kg mass, is also coming with the 9.6 meters per second along the shown direction. So basically that is a 60 degrees to the horizontal. Okay, now they are colliding at this point B, and then they both are moving along the y direction as shown. Now let's see the question. By considering the components of momentum in the direction from A to B, show that ball X has a mass of 4 kg. So by considering the components of momentum, so you must talk about the momentum components along x-axis and y-axis. So this let's resolve before we solve that question A. Let's resolve the moments of ball X and ball Y. So if you see, moment is usually represented by P, letter P, and then Px, momentum of X in X direction. Okay, there are two X, no need to confuse. The momentum of X in X direction is let's say the mass is m, so we don't know the mass actually, we are going to find mass. So the mass m times 3.0, the mass times velocity, right? Momentum is mass times velocity, that's why 3 times m times 3.0, which is equal to, let's say, 3m. So the momentum of x along y-axis, okay, momentum of x along y-axis is 0. Why do you say it is 0? Because the moment the ball, the x, is just moving in the x direction only. There is no y component of velocity, so there is no y component of momentum as well, so that is 0. Let's talk about the y now. So the momentum of y along x-axis is equal to, now, mass times velocity along x-axis. That's what important. Okay, mass times velocity along x-axis, and then momentum of y along y-axis is equal to mass times velocity of y-axis, velocity along the y-axis. Now how do you get it, Vx and then Vy? How do you get Vx and Vy? Let's see here. The velocity is 9.6 meters per second. The velocity is 9.6 meters per second. Now let's resolve. So this is x-axis and then this is a y-axis, right? This is a y-axis, this is x-axis, and then if this is 60 degrees, if this angle is 60 degrees, if this angle is 60 degrees, this angle should also be 60 degrees, right? According to geometry, right? So 60 degrees. Now this is 9.6 meters per second. So the velocity along the x-axis is equal to v cos theta. Okay, v cos theta, that is equal to 9.6 cos 60. So keep aside, just Vx is equal to 9.6 cos 60. And then what is a Vy? Of course, Vy will be equal to V sin theta. That is equal to V, which is 9.6 sin 60 is theta is 60 degrees, right? So 9.6 cos 60 is along x-axis, velocity of component of velocity along x-axis, and then 9.6 sin 60 is component along y-axis. Okay, velocity component along y-axis. Now just put the vx and then vy in this equation. So mass is 2.5 times, vx is cos 60. Cos 60 is how much? Cos 60 is 1 over 2 times 9.6. That is vx. And then mass is 2.5. Sin 60 is root 3 over 2 times 9.6. Why is it root 3 over 2? 9? Because sin 60 is root 3 over 2, like that. Okay, keep aside. Now coming back to the question. Okay, this is the background information that you need to know before you solve. Yeah, whenever there is a movement, whenever there is a object which is moving at certain angle to the horizontal, you should be able to resolve the components of the velocity. Once you know the components of velocity along x-axis and y-axis, you can calculate the momentum along x-axis and y-axis by multiplying the mass to that, like this. So the mass is equal to m times vx, momentum is m times vx, and then momentum along y-axis is m times vy. Now coming back to the question, by considering the components of momentum in the direction from A to B, show that the ball X has the mass of 4 kg. Now what is the key point to solve this question? Here, according to the conservation of momentum, any collision, be it elastic collision, be it inelastic collision, the momentum should be conserved before and after collision. That's the conservation of momentum. Like momentum should be same before and after collision, along x-axis as well as along y-axis, both. Okay, now let's see. Momentum, sorry if you cannot see, along x-axis before collision is equal to momentum along y-axis after collision. So that is if I write just momentum, it is actually an incomplete sentence. Is a net momentum. Okay, net momentum. Why is it net momentum? Because the system here has two objects, right, x and y. So the net moment of the system should be conserved in any direction. So net momentum along x-axis before collision. Now let's see. Now I'm talking about the before collision thing. Okay, so before collision thing, x has a positive momentum. Imagine the velocity in the towards x-axis is positive, and then in the negative x direction is negative, right? So the x has a positive momentum. What is the momentum here of x? 3m. That's it, 3m. Why is it 3m? Because mass is m and then velocity is 3, that is along x-axis. So let's say positive plus 3m you can write for the to be more specific here. And then let's see the y. The object is moving along the negative x-axis. Okay, moving the velocity component is along the negative x-axis. That's why the momentum will be mass times velocity in the negative component. So what is that? The 2.5 times half times 9.6, but it should be in the negative direction, right? So minus 2.5 times 1 over 2 times 9.6. That's a component of the momentum along x-axis before collision. This is the net momentum before collision, yeah, and then along the x-axis is equal to net momentum along the x-axis also, yeah, that one. Net momentum along x-axis before collision is equal to net momentum along x-axis after collision, right? So after collision, what's happening? The two objects are sticking together and then moving in the y direction. So there is no x component, there is no component of the velocity along x-axis, just like this one. See, the x had no y component along y component of velocity. Why? Because it is purely moving along x-axis, right? In a on the x-axis, and at the same time, the combination of the masses after collision moving along y-axis, which means the x component of momentum is 0. So basically you just can write simply 0. Okay, so the 3m is equal to whatever is the number. This is minus 2.5 times 1 over 2 times 9.6, right? It goes, what happens, it becomes positive, right? So 2.5 times 9.6 divided by 2. Then the mass, if you want to know the mass, definitely mass is equal to 2.5 times 9.6 divided by 2 times 3. So if you calculate that number, you will end up with 4.0 kg. 4.0 kg. That's the mass. We showed the mass is 4 kg, right? That's what they are asking. Show the mass of the object is 4 kg, right? That's what. Now let's go to the next question, which is B. Calculate the common speed of the two balls after collision. Okay, so we use the momentum, net momentum along x-axis before collision is equal to net momentum along x-axis after collision, right? So this is in one direction. The same formula, the same theory can be applied to here, to get the answer. But here we will apply the conservation of momentum along y-axis. Okay, so what is the statement? The net momentum before collision, net momentum along y-axis before collision should be equal to net momentum along y-axis after collision. So net momentum along y-axis before collision is what? Only y has a momentum in the y direction before collision. X has no. So basically how much is that? This much is a momentum along y-axis before collision. What is that? 2.5 times, we just calculated, right? So that came in handy now. Okay, so 2.5 times root 3 over 2 times 9.6, that is a momentum, net momentum along y-axis before collision, should be equal to net momentum along y-axis after collision. After collision is how much? So the mass is 2.5 and then the mass is 4.0, total mass is 6.5 kg, and then the velocity is v. So the 6.5 times v is a net momentum along y-axis after collision. So that is equal to 6.5 times v. And then the v, if you use the calculator and then find the v, what do you get? 2.5 times 9.6 times root 3 divided by 2 times 6.5 is equal to, I need to put it in the calculator, so let me see. So the velocity of the combination after collision is found to be, after calculating, you get 3.19, which is rounded off to 3.2 meters per second. Okay, now determine the difference between the initial kinetic energy of ball X and the initial kinetic energy of ball Y. So the difference between initial kinetic energy of ball X and the different initial kinetic energy of ball Y, which means kinetic energy of ball Y and minus kinetic energy of ball X. So what is the kinetic energy formula? What is the kinetic energy formula? Half mv squared, right? Half mv squared of y minus half mv squared of x. So this m is different from this one, this v is different from this one. Okay, so this is mass of y and then velocity of y, mass of x and velocity of x. So that is equal to half. The mass is mass of y is 2.5 times velocity of the y before collision is 2.5 meters per, sorry, 9.6 meters per second. Okay, 9.6 meters per second. So that is 9.6 squared minus half times the mass of the X is we just found from the question, that is 4 kg. Okay, so 4 times velocity of the X before collision. So velocity of the X before collision is 3 meters per second, so 3 squared. So that will be finally this, when you put this on calculator, you will get 115.2, and then this one you will be getting half times 4 is 2, 2 times 9 is 18, and then 115.2 minus 18 is 97.2, which is rounded off to 97. So 97 joules is difference of the kinetic energy, right? So thank you.